Students, from last 4 videos we are studying colligative properties, and from these already we studied 2. Today I am going to discuss third colligative property called as freezing point depression. Here freezing point first we have to define. Freezing point, you know that freezing point is the temperature at which liquid turns into its liquid. But in terms of vapor pressure, it is the temperature at which solid and liquid are at equilibrium. Solid and liquid are at equilibrium means vapor pressure of solid becomes exactly equal to liquid. Vapor pressure of solid becomes equal to vapor pressure of liquid. This is the definition for freezing point. If non-electrolyte is added to the solution, it is seen from some experiments that freezing point get lower. And today we are going to discuss detail about this lowering or depression in freezing point. For this we consider vapor pressure and temperature graph. We now consider consequence of freezing point with vapor pressure. With vapor pressure. For this I draw graph. Here one experiment is done. Pure solvent and solution. Their vapor pressure are noted at a respective temperature and graph is plotted. In this graph, we are going to take temperature on x-axis and vapor pressure on y-axis. We get for solid graph like this. This is for solid. Okay, and the graph for solution. Pure solvent. Pure solvent, it is from, I denote it by letters A to B for solid. Here it is pure solvent from B to C, and it is for solution. Now listen. Here AB is vapor pressure temperature graph for solid. BC is vapor pressure temperature graph for pure solvent. In this you see that they intersect at point B. At point B there is an equilibrium. Here we get equilibrium. Equilibrium means vapor pressure of solid state and vapor pressure of pure solvent becomes equal. At that point, the temperature is TF0. TF0 is freezing point of pure solvent. We denote it. TF0 is freezing point of pure solvent. Pure solvent. Now consider this one. Here we get solution of graph which is little below of pure solvent. Why? Because there is lowering in vapor pressure. First colligative property. When you add any non-electrolyte solute in solvent, vapor pressure get lower. Therefore, we get graph like this at low point. Here DE is for solution. Here E is then intersect with solid graph. Here vapor pressure of solid and vapor pressure of solution becomes equal. That means it is equilibrium. And according to definition of freezing point, we get here freezing point of solution, which is little bit low than pure solvent. From graph it is clear that freezing point get lowest. TF is freezing point of freezing point of solution containing non-electrolyte solute. And from graph it is totally clear that it get depressed. Freezing point of solvent get depressed due to addition of solvent. Okay. Why this happens? Now we study this. Why? असं का होतं? You know water molecule. I draw a structure. These are water molecules. In liquid condition. Okay. These are moving here and there. Not at steady state. Their movement depends on temperature. As you lower temperatures, if temperature get lowering, movement of molecules also decreases and intermolecular force of attraction increases. We now considering pure solvent. This is pure solvent. When we decrease the temperature, solvent molecules come closer and closer. Why? Because their movement decreases and intermolecular force of attraction increases and solid state is formed. Solid state is formed. If you consider solution, in case of solution, these are solute particles. Solute particles are present. These are solvent. We consider it as water molecule. To draw like this. Okay. This is solution now. In this solution, when it is in liquid state, these are moving here and there. There is less intermolecular force of attraction between solvent molecules or solute molecules. When we decrease the temperature, movement of these molecules become less. Intermolecular force of attraction also goes on decreasing. But at temperature where liquid freezes, pure solvent freezes, at this point these does not get into converted into solid particle. Why? Because when these are want to come to closer, here there are solid particles which are obstacle for that. If these solvent molecules try to come to closer, solute particles are there, and due to this, at this temperature it does not solidify. If you decreases again temperature, it get solidify, and therefore here freezing point depression is there. परत एकदा बघा, ज्यावेळेला हे मोलेक्यूल प्युअर सॉल्व्हंट कंडिशन मध्ये असतात त्यांची मूवमेंट काही ठराविक ठरलेली असते. फोर्स ऑफ अट्रॅक्शन इज लेस ॲज कम्पेअर्ड टू सॉलिड. ज्यावेळेला आपण टेम्परेचर डिक्रीज करतो मूवमेंट कमी होते आणि इंटरमोलिक्युलर फोर्स ऑफ अट्रॅक्शन वाढते आणि त्यामुळे त्याचा सॉलिडमध्ये कन्व्हर्जन होतं. हे प्युअर सॉल्व्हंटच्या बाबतीत होतं. T0F ला हे सॉलिडिफाय होतं, फ्रीज होतं. इफ यू कन्सिडर सोल्युशन मध्ये along with solvent molecule there are solute molecules also. If you decrease the temperature up to freezing point of solvent, this solvent molecule हे solvent molecule एकमेकांच्या तितकेशे जवळ येऊ शकत नाहीत कारण यांना ऑब्स्टॅकल ठरतं सोल्यूट मोलेक्यूल. इथं जे प्रेझेंट आहे ते सोल्यूट मोलेक्यूल मध्ये मध्ये आल्यामुळं यांना एकमेकांच्या मध्ये इंटरमोलिक्युलर फोर्स ऑफ अट्रॅक्शन हा कमी असतो ॲज कम्पेअर्ड टू प्युअर सॉल्व्हंट आणि त्यामुळं इथं सॉलिड होत नाही. अजून थोडं लो केलं टेम्परेचर तर मात्र मग यांचं सॉलिडमध्ये कन्व्हर्जन होतं, एकमेकांच्या जवळ येतात आणि सॉलिडमध्ये कन्व्हर्जन होतं. अँड इट इज लो, ते टेम्परेचर याच्यापेक्षा T0F पेक्षा कमी असतं TF. It is less. And the difference between these two, difference between T0F and TF is known as freezing point depression. This is the difference. Freezing point depression मध्येच पुढचा पॉइंट आहे freezing point depression and concentration of solute. कॉन्सन्ट्रेशन ऑफ सोल्यूटचा फ्रीझिंग पॉइंट डिप्रेशनशी कसं रिलेशन आहे हे आपण या पॉइंटमध्ये डिस्कस करणार आहोत. We know depression in freezing point delta TF is proportional to again m. M is nothing but molarity. In last boiling point elevation video we discussed about molarity. Molarity is number of moles dissolved per kg of solvent. Here proportionality sign if removed we get equation like this. Okay, here suppose this is equation 1. Here AF proportionality sign साठी जो आपण टाकलेला constant आहे it is also called as freezing point depression constant. Freezing point depression constant or cryoscopic constant or cryoscopic constant. Cryoscopic constant. We can define this. Define करण्यासाठी आपण मोलर हे 1 कन्सिडर करूया. If we take 1 molar solution m equal to 1, then equation 1 becomes delta TF is equal to KF. We can write it like this. Therefore KF is equal to delta TF. We can define from this cryoscopic constant. Cryoscopic constant is depression in freezing point of 1 molar solution. Cryoscopic constant or freezing point depression constant is depression in freezing point of 1 molar solution. We can also write units of KF. युनिट्स आपण याच्यावरून डिराईव्ह करू शकतो. काय ते बघा, युनिट्स आपल्याला फॉर्म्युला माहिती असेल तर आपण युनिट सुद्धा डिराईव्ह करू शकतो. फॉर्म्युला आपण डेल्टा टी एफ के एफ एम असा माहितीये. के एफ इज इक्वल टू डेल्टा टी एफ एम kf is equal to delta Tf. You can write in Kelvin or degree centigrade. In last video we discuss about this because delta Tf असू दे किंवा kf असू दे हे दोन्ही टेम्परेचर डिफरन्सच्या रिलेशन मध्ये येतं, त्यामुळे व्हॅल्यूवर फरक होत नाही. तुम्ही 273 ऍड करून डिफरन्स काढा किंवा न भरता काढा, डिफरन्स विल बी सेम. त्यामुळे केल्विन मध्ये घेतलं काय, डिग्री सेंटीग्रेड घेतलं काय, युनिट फक्त बदलेल, ती व्हॅल्यू बदलत नाही बिकॉज देयर इज डिफरन्स इन टेम्परेचर. केल्विन हियर युनिट इज मोल पर केजी. मोल per kg. By simplifying you can write Kelvin kg mole raised to -1 or degree centigrade kg mole raised to -1. These are units of depression in freezing point or cryoscopic constant. Freezing pointचा next part आहे. We can calculate molar mass of solute by using freezing point depression value. Next point is molar mass of solute from freezing point depression. Freezing point depression. We know delta Tf is equal to Kf into M. This is equation 1. We have to calculate M, molarity of the solution. For this, we consider W1 amount of gram of pure solvent. W1 gram of solvent. But for molarity, we need it in kg. Therefore, we can write W1 into 10 raised to -3 kg of solvent. We dissolve W2 gram of solute. Suppose W2 gram of solute is dissolved in W1 gram of solvent, and M2 is molar mass of solute. From definition of molarity, we can write M is equal to number of moles of solute. W2 by M2. Number of moles we can calculate by this formula W2 by M2. And it is again divided by 10 raised to -3 into W1. हे थोडंसं सिम्प्लिफाय केलं की आपल्याला असं मिळेल 1000 W2 divided by M2 W1. This is value for M. Now use this value in equation 1. We get काय मिळतं बघा आपल्याला, डेल्टा TF M ची व्हॅल्यू घालूया तिकडे, KF 1000 W2 divided by M2 W1. And from this relation, you can calculate value of molar mass of solvent. M2 is equal to only delta T. You will have to transfer 1000 सुरुवातीला घेऊया KF W2 divided by delta TF W1. And from this relation, we can calculate value of molar mass of solute. जर तुम्हाला KF माहिती असेल क्रायोस्कोपिक कॉन्स्टंट, W2 माहिती असेल, डेल्टा TF डिप्रेशन फ्रीजिंग पॉइंट माहिती असेल आणि W1 म्हणजे किती ग्रॅम ऑफ सॉल्व्हंट आपण यूज केले ते माहिती असेल तर याच्यावरून मोलर मास कॅल्क्युलेट करू शकतो.